Welcome back to Chemistry 1032 Instructional Videos. I am your host, Dr. Russell Betts, and I'll be guiding you through Chapter 5.4, Oxidation and Reduction. Now, two ways to talk about oxidation reduction. One will involve metal ions and the movement of, and let's circle the word electron here, electrons. So metal ions and the movement of electrons is one way to define oxidation and reduction. And another way, here we go, is the removal of oxygen and hydrogen. Okay? That's the organic way. So there's two ways to look at this. Either it's going to be the addition or the removal of oxygen and hydrogen, which is the organic way. That's really the simplest way. Or it'll involve a metal ion and the movement of electrons. That's a little bit more challenging, but also very simple. Okay? So these words, oxidation and reduction. We're going to learn two different definitions. So here we are. We're going to talk about the inorganic way first. In a inorganic reaction, the loss of electrons is called an oxidation. So in a reaction, one of these two species up here is going to lose electrons. The other one is going to gain electrons. Okay? Because the gain of electrons is a reduction. So oxidation, lose electrons. Gain electrons, reduction. And I remember that by just writing out Leo, Gur. Leo the lion says Gur. That's the saying. Leo the lion says Gur. Lose electrons, oxidize. Gain electrons, reduction. Pretty neat, huh? Lose electrons, oxidize. Say it with me. Gain electrons, reduction. Lose electrons, oxidize. Gain electrons, reduction. And that's how it works. Okay, guys. I thought I would whisper it to give it more dramatic effect. Maybe you write it down in your notes and remember it for the exam, quizzes. Well, no quizzes, I guess. Exams and assignments and all that stuff. Okay? Now, here's some things you should know. Oxidized species is also known as a reducing agent. So the species that is oxidized is sometimes referred to as a reducing agent. Let me get my face out of your way here. The species that is oxidized is sometimes referred to as a reducing agent. And the reduced species is sometimes referred to as the oxidizing agent. What does a reducing agent mean? A reducing agent causes something else to lose electrons. Okay? To gain electrons, pardon me. Okay? An oxidizing agent causes something else to lose them. All right? That's just another way of referring to them. Let's see if we can get a couple of the cool examples here. So here's an example. We have lithium plus chlorine giving us lithium chloride. Now, one of those reactants is oxidized and the other one is reduced. Now, I want you to remember one thing. In a chemical reaction, if there's an oxidation occurring, there must be a reduction. It's like a rule. If something is oxidized, another thing must be reduced. Now, first thing I would write down here is Leo Gur. There's no carbon or hydrogen in here, so we can't use the organic way of doing this. We have to use the electron way. Lose electrons, oxidize, gain electrons, reduction. Good enough. Now, to examine this, we have to figure out who's losing electrons. Who is losing? Well, on the left-hand side, we have lithium, and that's lithium metal, and it has zero charge. Has zero charge. What does that mean? That means it's the atom lithium. So the atom lithium. And on the right-hand side, well, we have lithium chloride, right? And that's lithium with a plus charge, Cl with a minus charge, right? It's an ionic compound. Lithium plus, chloride minus. So on the right-hand side, lithium actually has a positive charge. Let's think about that. Lithium on the left has no charge. Lithium on the right has a positive charge. Well, look at my periodic table I have on my wall here, and I find that lithium is element number 3. So lithium has 3 protons and 3 electrons for a grand total of no charge. That's the lithium atom. Now over here on the right, the protons are positive 3. The electrons, let's just say we don't know. But we know the overall charge is positive 1. Okay? That's interesting. Okay, how many... Well, let's do some arithmetic then. How many electrons must be here in order for this math to work? It must be negative 2, correct? In order for this to be positive 1, plus 3 minus 2 is plus 1. Going from left to right, that's a loss of 1 electron. Are you with me? It's a loss of 1 electron going from left to right. So far, so good. Loss of 1 electron. Lose electrons, oxidize. So the lithium is oxidizing. You can just put OXID if you want. I get the idea. Lithium is oxidizing. Ha! Lithium lost electrons. And who did he give his electrons to? He has to give them to somebody. Well, the only other creature in here is chlorine, right? He must have given it to chlorine. So let's do some quick math here. Let me see if I can manipulate here. Oh, okay. Here we go. I need a blank slate here. Hold on, guys. There we go. Blank slate. There we go. We just did lithium. Now let's look at it from chlorine's point of view. Light went off again. Come on. Come on, light. I look like an idiot here, light. Are you serious? Okay, here we go again, guys. Now let's look at it. We looked at it from lithium's point of view. All right, we looked at this from lithium's point of view. Now let's look at it from chlorine's point of view. So here we have chlorine, Cl2, going over here. It's going to be Cl minus because remember it's lithium chloride, lithium plus Cl minus. It's ionic, right? Remember all that stuff we learned before about ionic bonds and stuff? Yeah, you have to know it. So here we go. Here it is again, right? Chlorine, I think, has 17 protons. Let me check my periodic table. 17. Yes, I know there's 2 chlorines here. I know everyone's wondering, like, well, there's 2 chlorines. There shouldn't be 34. Yes, there's 34 protons total on the left-hand side. But I want you just to think about it as terms of 1. Just think of it as 1 chlorine. It makes this life a lot easier for you. We could balance the equation and do it out that way, but you'd drive yourself nuts doing it. Just do it with 1. Trust me. Now over here, the charge is negative 1. So the electrons must be negative 18. That's the gain of 1 electron. Oops. The gain of 1 electron. Now, I get it. I get it. 18 is lower than 17. How can that be a gain? I get it. It doesn't make any sense to you guys. Think about electrons not as negatively charged particles. Think of them as golf balls or tennis balls or soccer balls or baseballs or whatever ball you want to think of. Just think of them as balls. Over here, I have 17 basketballs, ping pong balls, whatever. And over here, I have 18 balls. So I've gained a ball. Those balls happen to be negatively charged, but we've gained a ball. Okay? So we've gained electrons going from left to right for chlorine. So chlorine is reduced. And you can just write red if you want to. Okay? Chlorine is reduced. So lithium is oxidized, chlorine is reduced. So lithium gave up an electron, gave it to chlorine, who accepted the electron. Leo the lion says grr, right? Remember that, Leo. Oops. Leo, grr. Leo the lion says grr. Gain electrons, reduce. Chlorine from left to right gained electrons. So chlorine is reducing. Lithium is oxidizing, chlorine is reducing. I get it. It's hard. It's kind of weird. First time seeing it, strange. Go over the video again. Read the textbook. Go to other online resources. Make sure you understand this. It's fundamental. It's actually part of the hemoglobin system, oxidation reduction. So make sure you understand it. Now, here's another way to think about oxidation reduction in terms of electrons. It's kind of your book's way. The phrase is oil rig. Oil rig. Oxidation is loss. Reduction is gain. That's how it works. Now, generally speaking, metal atoms lose electrons. So metal atoms oxidize. Generally speaking, non-metals gain electrons. So non-metals reduce, generally speaking. Okay? So if something forms a cation, it's oxidizing. If something forms an anion, it's reducing. And if you want, you can use the book's mnemonic called Oilrig. I like Leo the Lion Says Grr. You might like Oilrig better. Whichever one you want to use, they both work. Now here's a quick little introduction to some relevance here. Here we have part of the, what is this, cytochrome C? Yeah, cytochrome C. Part of a protein called cytochrome C. It's very important in ATP, adenosine triphosphate production, which is the energy for the body. Now this contains an iron plus 2. And when it undergoes a reaction, it will actually become iron plus 3. So going from left to right, the iron actually loses an electron somehow. Don't worry about how, it just does. Okay? So going from left to right, the iron actually loses an electron. Leo the Lion Says grr. Lose an electron. So it's oxidizing. So going from left to right here, the iron inside this protein is actually losing electrons or oxidizing. Pretty neat, huh? So this is very biologically relevant. Very biologically relevant. So you have to understand oxidation reduction even to the point of the electron. Even to the point of the electron. Not a problem. You have to practice it. Just get used to seeing it. And it's actually very simple once you get used to seeing it. But you have to practice it. If you don't, it's not going to be very easy because you haven't practiced it. Try riding a bicycle if you've never practiced it. You'd probably fall flat on your face, right? But you practiced it, and now you're good at it. See how it works? Okay. Organic oxidation reduction. Much easier, in my opinion. Much easier to deal with. In an organic molecule, oxidized if it gains oxygen or loses hydrogen. Okay? An organic molecule oxidizes if it gains oxygen or loses hydrogen. And it's reduced if it gains hydrogen or loses oxygen. So an oxidation is the gain of oxygen. A reduction is the loss of oxygen. One more time. Oxidation is the gain of oxygen. Reduction is the loss of oxygen. Okay? That's likely where these names came from. Oxidation, gain of oxygen, reduction, loss of oxygen. That makes sense, right? If you oxidize, oxygen's in the name, ox, that's an oxidation, gain oxygen. Reduction, reduce the number of oxygens you have, is a loss of oxygen. So that's probably where these names came from. Now, an oxidation is further defined as the loss of hydrogen. So that's also a definition for oxidation. It's the loss of a hydrogen atom. Reduction is a gain of hydrogen atom. That's another definition, another way of looking at it. So write them both down. They're both important. Now let's look down here. We're going to start here with aldehyde. Okay, we're going to start with aldehyde. Excuse me. Pardon me, guys. Now, if we're going to do a reduction, we're going to go from, say, this way. Notice how this carbon only has one hydrogen, right? Only has one hydrogen. But over here, that very same carbon now has 2 hydrogen. So that carbon has gained a hydrogen. Gain hydrogen is a reduction. It's a reduction. Over here, looking at, let's change colors, looking at this carbon right there, it has 2 bonds to oxygen. It has 2 bonds to oxygen. Over here, oops, let me try a little differently. That carbon has 3 bonds to oxygen. Now, oops, let me draw that a little bit neater for you guys, sorry. Three bonds to oxygen. Now, I know what you're thinking. I know what you're thinking. Why am I talking about bonds? How come I don't just talk about the total number of oxygens? Well, it's a good question. Notice on this molecule here in the front, the very center, that carbon only has one oxygen, right? So does that one. They both have one oxygen. But let me just back up here and get my drawing nice and clean here. So notice one oxygen. But this one is a reduced form of that one. Okay? So the alcohol is a reduced aldehyde. Now, be very careful. This molecule here only has one bond from carbon to oxygen. This one here has 2 bonds from carbon to oxygen. That's important. It's not just the number of oxygens you have, it's how many bonds you make to it. Okay, I know it's a little weird, but that's how it works. Notice, 1 oxygen, 2 bonds. 1 oxygen, 1 bond. See how that works? So if you have 2 bonds to oxygen and you all of a sudden have 1 bond to oxygen, you're reduced. Here, we have 2 oxygens. So that's obviously an oxidation, but if you want to look at it a different way, there are 3 bonds to oxygen as well. Three bonds to oxygen. Now, it happens to be that one of the oxygens is the same oxygen being bonded to twice. That's okay. Don't let that worry you. Don't let that phase you a bit. That's okay. Just count the bonds to oxygen. That's what I usually do. I find that to be easiest. Okay? So, one more time. Let's go over this one more time. I'll make sure everyone's got it because it's a very, very critical point in chemistry. And there we go. Let's do it in blue. Why not? Over here, we see that this carbon has 2 bonds to oxygen. That carbon has 1 bond to oxygen. This carbon has 1 hydrogen. This carbon has 2 hydrogen. So it's reduced. 2 ways of looking at it. Bonds to oxygen or number of hydrogens. Let's go the other way. This carbon has 2 oxygens. This carbon only has 1 oxygen. So this is an oxidation going here. Oxidation. Pretty neat, huh? Let's do. Now, obviously, I think everyone can see this carbon has 2 bonds to the same oxygen. 2 bonds to the same oxygen. This carbon has those 2 bonds right there, but it also has that bond right there. Okay? Oxidation, reduction. And my light's off again. Okay, let's take a look at this reaction right here and try to figure out, is the carbon undergoing an oxidation or a reduction? So I think most of you can just look at it and go, yeah, it's an oxidation. But let's take a little closer look just to be sure. Here we have the Lewis structure of methane going to CO2. Now, obviously, this carbon has 4 hydrogen. This one has 0 hydrogen. Let me do that differently because it looks like OH. 0. Z-E-R-O. 0 hydrogen. Okay? So going from left to right, the carbon atom is losing hydrogen. Losing hydrogen is an oxidation. It's also gaining oxygen. And gaining oxygen is an oxidation. Isn't that cool? See how easy that is? Now, again, if there's an oxidation, there must be a reduction. So if this carbon is oxidizing, the oxygen itself must be reducing. All right? Now that sounds a little weird. I know people don't like oxygen can reduce. Absolutely it can. Oxygen is an oxidizing agent. Oxygen can very easily donate oxygen, right? By definition, if you're oxygen, you can donate oxygen. You know, if you're chlorine, you can donate chlorine. It's just how it is, right? So oxygen is most definitely being reduced in this reaction. Pretty cool, huh? Pretty simple, but you got to get used to looking at it. Like, I don't want you to be on an exam and having this be the first time you hear or see this stuff, because then won't know what to do. Practice the problems in the book. Work the stuff we do in class. Make sure you understand that. And this stuff's pretty simple, but you got to work it. All right? Like everything else in life, you have to work with it. Now, in your cells, oxidation is a big deal. Oxidation is a huge deal. Now, we fuel our bodies with nutrients that are broken down through oxidation. That's how we work it. Okay? For example, good old ethanol is oxidized to this aldehyde called ethanal, also known as acetaldehyde, through this enzyme, here's that word enzyme again, called alcohol dehydrogenase. It takes your alcohol, which I will draw for you here. Here's the condensed structural formula of the alcohol that we drink. Well, some of us drink. And it makes this. Let me do that differently. There we go. So take a look at this carbon right there. The carbons with the red arrows pointing at them are the same carbons, okay? Now, I think everyone will agree this carbon over here has 2 hydrogens bonded to it. 2 hydrogens bonded to it. Now, if you look over here, that carbon only has 1 hydrogen bonded to it. Loss of hydrogen is oxidation. Okay? So this carbon is being oxidized by alcohol dehydrogenase. Okay? Now, again, if there's an oxidation, there must be a reduction. Okay? And in the case of alcohol dehydrogenase, that reduced molecule is this one here, nicotine amide adenine dinucleotide, more affectionately known as NAD+. NAD+. Now, these are 2 important molecules used in the metabolic oxidation reduction reactions. And let's take a look at a schematic involving NAD+. So here's oxidation. Here's the ethanol. And here's the acetaldehyde that I was talking about. Now, this is NAD is going into the reaction. Now watch what happens. NAD picks up a hydrogen. Gain of hydrogen is reduction, right? Gain of hydrogen is reduction. This carbon right here is becoming this carbon right here, losing hydrogen. That's an oxidation. Okay? So this molecule is oxidized. This molecule is reduced. It takes a hydrogen. Okay? This molecule gives up one of the hydrogens on that carbon. This molecule accepts the hydrogen from that carbon. Okay? Where there's an oxidation, there by definition must be a reduction. Pretty neat, huh? Pretty cool. Biological examples are awesome. And that brings me to 5.5. So we'll pause the video here. And don't forget, guys, go over all this stuff. Make sure you understand oxidation reduction. Make sure you understand Leo the Lion says GUR or Oilrig, however you want to do it. Make sure you understand that oxidation is the gain of oxygen or the loss of hydrogen. And reduction is the gain of hydrogen or the loss of oxygen. Make sure you get that stuff. It's very easy, but you have to know it. All right, guys? So now with that, I want to wish you guys good luck and good chemistry.